So you're working on the equation of a circle right now and trying to figure out where this equation comes from. X minus h squared plus y minus k squared equals r squared. You go, that kind of looks like the Pythagorean theorem. Something squared plus something squared equals something else squared. But where exactly does that come from? I want to walk you through how to derive this equation so that it makes a little more sense and it's not just being you're not being told that you have to just memorize this thing, but you can see where it comes from. Okay, so I've got a circle in red with the center in blue, and we're going to call the center H and K. H is the X coordinate, K is the Y coordinate. This green XY here is just literally any point on the circle. The very first thing we ever talked about with a circle and the way we defined it is that a circle is made up of all the points that are the same distance away from another point, which in this case is the center. And we have a term for what that distance is called, right? It's called the radius. Again, I'll have a lot of stuff off to the left here. Don't worry about it. This black dotted line here is a radius. The radius is the length from the center to any point on the circle. And the fact that it's a circle means that this radius is always the same length no matter where your point is on the circle, right? So xy is just going to represent any point on a circle. I'll leave it right here. By the way, this first example will be with letters. The next one will be with numbers so you can get a better numerical example. So the radius, how do I figure out how long this radius is or how much of a distance this radius covers? Well, we have a couple ways to do distance, either the distance formula, which is long and given to you on your reference sheet, or a lot of you ended up just doing the Pythagorean theorem. I can't just calculate this by counting. I could if it was something like this, straight horizontal, then I could count the distance. Or something like this, straight up and down. And notice that there's no grid for me to be able to count boxes here. So I have to try to do some other things here to figure out this distance. If my distance is slanted, we'll use the Pythagorean theorem. Pythagorean theorem is our a squared plus b squared equals c squared, right? And I'm going to draw in a right triangle so that I can figure out the side lengths and do a squared plus b squared equals c squared. So first question is, what is this distance down here, this horizontal distance? When we calculate distances, one of the things we tried to nail is that you're doing subtraction, right? You might think, well, distance, that should be adding. If I said, hey, how far apart are 9 and 4, or 5, right? How far apart are 9 and 5? You wouldn't say they're 14 apart. You would say there's 4 numbers between 9 and 5. You're subtracting. The distance between 9 and 5 is 4. What if we had two negative numbers? How far apart are -1 and let's say -6, right? Well, they're 5 numbers apart between -1 and 6. And to get that, I have to do -1 minus -6. That means the distance between them is 5. We always subtract to find distance. Okay, that's the key part of this to remember. Because a lot of you will do something like this. Well, we'll get to that in a second. So the horizontal distance here, horizontal deals with the x coordinates, whatever comes first in your ordered pair. So x and h. That means that my distance here horizontally, I'm going to subtract the two x coordinates and get x minus h. That's the length of this thing here. If x here was 5 and h here was 3, 5 minus 3, this would be a length of 2. 5 and 3 are 2 apart. Same exact thing for the vertical distance. Now I'm looking at the y coordinates. The y coordinates are y, comes second, and k, that comes second. So that would be a distance of y minus k here. So then I can do a squared plus b squared equals c squared. That would be x minus h squared plus y minus k squared. And that'll be equal to this hypotenuse here squared. And what did we say this hypotenuse is? It's the radius of the circle, right? This is the radius. So if I do this squared plus this squared, it should equal this squared. That right there is the definition, or sorry, the equation of a circle. X minus h squared plus y minus k squared equals r squared. It's just the Pythagorean theorem, but written generically for any point on the circle. Notice that no matter where this point is, the dimensions are still the same if I use generic variables. X minus h is the horizontal distance, y minus k is the vertical distance, and the radius is the same. It's always the hypotenuse of that right triangle. So that's where that comes from. Why they use H and K for the center, I'm not sure. You could call it A and B or C and D, whatever you want is fine. But that's where that comes from, okay? Let's do one with specific numbers so that you can get a numerical example here. Let's say our center is 2, 3, right? So again, this is a circle. I got to point X, Y anywhere I want, and I'm trying to figure out that this is the equation of the circle. And what a lot of you have said in the past is like, all right, it's positive 2, so I should have X plus 2 plus Y plus 3 squared, since those are positive, but notice that that doesn't work, right? These have to be negative in order for it to work. Oops. There you go. So again, where is that coming from? Well, this is pretty much going to be the exact same deriving here. I have a radius, and to calculate the length of this radius, I got to make my right triangle and do the Pythagorean theorem, right? So what is this horizontal distance? I look at the x-coordinates, x and 2. To find distance, we subtract. That would be x minus 2. How about the vertical distance? Now I'm looking at the y-coordinates, y and 3. So that vertical distance, I would subtract and get y minus 3. That's how long it is. Again, let's say this point xy here is, I don't know, 5, 6. Well, I know that 5 and 2 are 3 apart because 5 minus 2 is 3. And 6 minus 3 is also 3, so this would be a distance of 3, right, just by subtracting. Okay, and so that should give me whatever this radius is here for the circle. I think I drew it so that it happens to be 7. Doesn't matter what number this is. But let's see if I plug these parts into the equation of the circle. Let's do it in a different color here and see if we get the same thing. So Pythagorean theorem is all the equation of a circle is. X minus 2 squared, and let's make this a different, well, I'll work with it later, plus y minus 3 squared. That should be equal to the hypotenuse squared, which in this case is 7. So it should be equal to 7 squared. And notice that's the exact same circle, just on top. Okay? So that's where it comes from. It's really just the Pythagorean theorem disguised by using the center and x and y to represent any generic point on the circle. That's it. Hopefully that'll help you kind of see where this comes from so that you don't have to necessarily memorize it, and hopefully it makes a little more sense now after watching that.